In this video, I'll be evaluating a series parallel circuit, and we'll be answering the following questions. What is the total voltage? What is the total resistance? What is the total current? What is the voltage across resistor R1? What is the voltage across resistor R2? And what is the voltage across resistor R3? We will also be finding the current through the 300 ohm resistor, I1. We will be finding the current flowing through the 400 ohm resistor, I2. And we'll also be finding the current flowing through the 500 ohm resistor, I3. Now, what is the total voltage? So here we have a series resistance in series with a parallel combination across a 10 volt source. So you can see that the 10 volt source is across both of these, which means that 10 volts is the total voltage. Now, what's the total resistance? The total resistance is the series combination of the 300 ohm resistor plus the parallel combination of the 400 ohm resistor and the 500 ohm resistor. So it's 300 ohms plus, now the question is, plus what? Because here you have 400 ohms and here you have 500 ohms. What we have to do here is take this parallel combination and convert it into an equal resistance or equivalent resistance. And the formula for that is R parallel equivalent equals 1 over 400 ohms plus 1 over 500 ohms. Now I'm going to put a little -1 at the top right here. That -1 means I'm going to take the reciprocal of this value here, and that will give me the resistance or the equivalent resistance of the parallel combination. So we have 1 over 400 ohms plus 1 over 500 ohms then we take the reciprocal, and that gives us 222 ohms. Then we add the 300 to the 222 ohms, and that gives you a total of 522 ohms. Now, I'm going to clean this up a little bit right here. So we have a total resistance of 522 ohms. Now the parallel combination, R parallel RP equals 222 ohms. Now I'll be getting back to the 222 ohms a little bit later. Now we have to determine what the total current is. The total current equals the total voltage of 10 volts divided by the total resistance of 522 ohms. That equals 10 volts divided by 522 ohms. That equals 0.019 amps. Now, what is the voltage across resistor R1? The voltage across resistor R1 is the total current multiplied by the total, or the 300 ohm resistor. So you have 300 ohms right here times the total current of 0.019 amps. That gives you a voltage across R1 of 5.7 volts. Now we're going to get back to the 222 ohm resistor, because in order for me to determine the voltages across the 400 ohm resistor and the 500 ohm resistor, I have to calculate that value using the 222 ohms of parallel resistance, or equivalent parallel resistance. So we have 0.019 amps times 222 ohms. That gives you a voltage across the 400 ohm resistor of 4.21 volts. Now, since the voltage across the parallel resistance of 222 ohms is 4.21 volts, that means that the 400 ohm resistor is 4.21 volts, and resistor R3, the 500 ohm resistor, also has 4.21 volts across it, because these two resistors share the same voltage. Now the next question is, what's the current through R1, the current through R2, and the current through R3? The current through R1 is the total current of 0.019 amps. Now what happens is, when the 0.019 amps reaches this node right here, it splits. Some of the current flows through the 400 ohm resistor, and the rest of it will flow through the 500 ohm resistor. Now, how do we know which is which? You apply Ohm's law. We know that across across the 400 ohm resistor is 4.21 volts. So we go 4.21 volts divided by 400 ohms equals 0.0105 amps. Now we know that the 500 ohm resistor shares the same voltage with the 400 ohm resistor because these two resistors are in parallel. So we go 4.21 volts divided by 500 ohms equals 0.0084 amps. Now what happens is you have the 0.0105 amps flowing through the 400 ohm resistor, and you have the 0.0084 amps flowing through the 500 ohm resistor, and both of these currents will meet at this junction right here and recombine back into that 0.019 amps we initially started off with. So the current at this point equals 0.019 amps, and that 0.019 amps flows back through the circuit and back through the 300 ohm resistor, comes back down to the parallel right here. These parallel resistors split again and repeats the process. And this brings us to the end of the video, and I'll see you in the next video.